Alrighty, so we're going to get started here. So what we're looking at today is the Cartesian planes. This is the four-quadrant grid that we use that is named after a gentleman by the name of René Descartes. And so the idea is that we have a coordinate grid of x and y axes, so it's two-dimensional. Everything happens in these two dimensions. And so we're going to take a look at some of the questions and take those up. Here I've drawn out a grid, and again, if you want to draw a grid on a piece of paper, I found an easy way to do it is just to take a second sheet of paper, fold it, and have the lines perpendicular. And then what I did was I just marked off some points at the bottom here. I marked off some points at the top, and then used a ruler to connect the lines, and I was able to make myself a grid on a piece of paper. I thought that was a pretty neat and easy way to do it. It's the most effective way I've found so far, other than just trying to measure it all out with a ruler. I found that using the two pieces of paper made it a lot quicker. So that's how I made the grids that you'll see on here. You don't have to draw the horizontal lines because there's already lines on the page. I just felt it was neater, and I had a few minutes to do it. When you're working with the grid, it's always labeled as X and Y, unless you're working with specific other letters. It might be distance and time, or distance and height, or speed and time, things like that. But if you're not given anything, we generally just use an X and a Y as our default grid axes. So the axes don't have to be centered. Generally, we work with centered because it balances nicely, but in some of the questions you'll note that they're not always centered, and it just depends on the situation what fits our current needs. So as we're going through this again, if you have any questions along the way, you can shoot them through the YouTube chat, or you can do it through email or Edsby messages, and I'll be checking those throughout the course of the video. So before we get started and actually plotting some points, just a couple key terms, and I'm actually going to flip over to the textbook portion. And so this wasn't an assigned question, but in the textbook there was a couple pieces. I'm going to zoom in a bit here. And so in the question number 1, it actually had matching terms. A couple key ones that are good definitions to be familiar with, again, is the term Cartesian, term A, Cartesian. And so the Cartesian is the term named after René Descartes to describe the Cartesian plane. So when we're talking about Cartesian, we're talking about this XY grid in two dimensions. In the next one, an ordered pair is another important one. So an ordered pair is always going to be written in a set of parentheses, but it's a position on the Cartesian plane indicated by an x coordinate followed by a y. So it's always in alphabetical order, x, y, and those will be in parentheses, as you'll see in a moment. The axes are another key area there. So the axes are that main 0, x, and y, where we start at 0, 0 with our numbering. And then the origin is the center of the grid. I did switch the date to Wednesday as well. I have a meeting tomorrow afternoon, and so I use Wednesday as our meeting date for those asking. So a couple definitions there. Anyways, if we look at some of the questions, we have a few that we're going to look at. Question number 2 here, where we're plotting some points. So we'll do a couple of those just to practice plotting. So the whole key here is just to kind of get familiar with the Cartesian plane. So we're going to do 2A and B. I'll switch over to the note here. And so now I have my grid. I've labeled it X and Y. And then I have my list of points. So these are those ordered pairs. Ordered meaning they're in order of x, y, and they're in parentheses, and these provide the coordinates on the grid. Now, numbering is dependent on just how big you want to get. To fit all of this, I would have actually had to double the size of this grid if I wanted to keep it nice and square like this. So I would have had to bump it up because it goes up to 12. Instead of doing that, what I'm going to do is I'm actually going to count each line as 2. So I'm going to count by 2. So if this is that origin, that's 0, 0. And then each of these lines, I'm going to name them 2, 4, 6, 8, 10, and 12. So right in between would be 9. And we're going to do it that way. So they go negative on the opposite side. And then that should be a positive, not a negative up there. And then we're counting up into the positives and then down into the negatives. Negative 2, negative 4, negative 6, negative 8, negative 10, and negative 12. So that there labels all those points for us. And then all the grid lines and that. Now we can use those to work. And just gonna give me a second here. Save, and I'm just updating something on the website. Okay, so posted that. All right, sorry, back to the questions here. So now we're going to actually go about graphing this, or plotting these points. So we're not actually graphing them, we're just plotting points. I'm going to use red for A and blue for the B points. And so now if we plot these out, we read them x, y, so it's along the x-axis is 4 and 3. So we don't put a point at 4, we don't put a point at 3. We put a point where they intersect. So 4 and 3 will be a point right here. And so that would be 4, 3. 3 and 5 would be over on the x-axis to 3, and then up to 5, which would be right here on the y-axis. That matches up there. And so that would be 3 and 5. So it's always you're going along the x-axis first, then on the y-axis. Negative 2 and 6 would be up here. And again, we're not putting points at negative 2 and 6. We're putting points where negative 2 and 6 intersect. 12 and 3 go over to 12 on the x-axis, up to 3 on the y-axis. And I'm labeling all my points right now. We don't always have to label our points, but I find it when we're getting started, it's good to label our points so that we remember how we're reading these. Last one, negative 7 along the x-axis, and then up to 4. So that matches up right there. Negative 7 and 4. So that's the first set of points for A, all plotted. So again, they go in order x, y. Every time we go along the x-axis, find it, and the y, and then we find out where those 2 points, or those 2 values intersect on the grid. So in the case of B, we have negative 1, so we go back to negative 1, which is right here, and then 0 on the y-axis, which is where we are already. So this line here is the 0 line, so the point is -1, 0 right there. And the next one is -3 and 10, so that is way up here. And then -3 and -5, so that one goes down to here. So -3, -5. And then the last one is -6 and -3. So we go along the x-axis to -6 and then down to -3. And so we have a point located right here. So again, whenever you're plotting these points, you're reading the x value first going along the x-axis, and then the y value second going along the y-axis, and then you're finding where those two values intersect like this. So that's some practice with plotting points. And then in the next one I want to look at was number 4. And in number 4 here, what we have is a series of points already listed on the grid, and we want to determine what their coordinates are. So I'll write these down as I'm doing them, but then I'll just keep the graph up, and then we'll look at the answers after we go through all 5 points. So if we look at point A, it is along the x-axis, it's at -3, and the y-axis, it's at 1. So its value, its coordinates in ordered pair is -3, 1. And so there we have it there. So it's written like this. Again, the x value, comma, the y value in parentheses. The b value, if we go back and look at the b value is at 5 along the x-axis, and then it doesn't go up or down from the 0, so it's 0 on the y-axis. So the coordinate is 5, 0. And so that looks like this here. The next point, C, on the x-axis, it matches up with 3, and on the y-axis, it matches up with 3. So the coordinates are 3 and comma 3. And so that looks like that. The next one, D, is over to -2 on the x-axis and down to -3. So -2 and then -3 on the y-axis. So -2, -3 is the ordered pair. And then the last one, or the next one here is E. And so E, all the way up at 4 near the top there, but it's 0 on the x-axis and 4 on the y-axis. So the value is 0 and 4. And then that last one is F. So F is located down at 4 on the x-axis and then -2 on the y-axis. So 4 on the x-axis and -2 on the y-axis. And so the coordinates are 4, -2. So all the ordered pairs are written xy, 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 always in that same order. And as long as you can kind of remember that horizontal, then vertical, and if you note that horizontal is also before vertical when you look at the first letter of the alphabet, then that should help you remember your x and y in which order. But everything is in alphabetical order for these. The next question I wanted to look at was number 6. I had assigned A and C, but I'm actually going to do D just for something different. You're plotting points again. This time the difference was we're connecting them. When you're asked to connect points on the graph, if you're given a list of points, then you would connect them in the order that you put them down. So, for example, I'm just going to draw this shape out here, and I'm actually set my scale on my graph here first. So I don't have a scale on this graph. The highest value I need to go to is +6 on anywhere. The highest value is +6, so that'll fit on the graph if I go. And instead of counting each square by 2, I'm going to count each value by 2. So it's 1, 2, 3, 4, 5, 6. I'm just writing every second one, just so it's a little quicker for me to write out here. You don't have to label every line. Right, 6. Sometimes it's actually neater and easier to read if you label every second line on your grid. So I've labeled those labeled the grid now. This is my x-axis, this is my y-axis. And so now I can plot those points. I'll do that in red. So the first point is -3. So there's -3, -4. And so I have a point at -3, -4. And the next point is at -2 and 1. So that's right here. Now, because these are listed in order, I'm going to connect them in that order. So I'm going to connect the first point to the second point. Next, I'm given the point 5, -4. So go over to 5 and down to -4. And then the last point was 6 and 1. And actually don't like the way they listed these. These should have been listed in the opposite order, because that actually makes it confusing. If you look at that, if I was to connect them in order, I'll do that lightly in pencil here, I would get this N shape. So it's not really a shape. And what points do you connect? Do you make an X? Because is that a shape? Is it this hourglass shape? What shape? This wasn't. This may not have been the best question in terms of laying out those points, because I would have laid them out in the opposite order of these last two, because then I could have went from here to here, and I think the expectation is to make yourself a parallelogram. So here we would have a parallelogram. I believe in A, you're looking at a triangle, and in C, you were looking at a square. So here we have this parallelogram. Just going to make that red line a little more of something that stands out. So we want to get the area of it, and the reason why I picked this one was just so that you could see counting sizes. So you need the area. Area of a parallelogram is equal to the base times the height, very similar to the length and width of a rectangle, except because it's skewed over, it tweaks it a bit. But our base we can simply find by counting 1, 2, 3, 4, 5, 6, 7, 8. So it goes over 8 squares. So our area is 8 by, and now the height is nice because we can count this little straight line here from the bottom to the top. 1, 2, 3, 4, 5. 8 by 5, and thus our area in this case is 40 units squared. And so you could actually, and if this was a square, you could actually count out the number of squares inside to find the area as well, and that would be kind of evidence of the idea that an area is made up of a whole bunch of little squares. In this case, because it's skewed, and again why I picked it, we can just count the number of squares for the base and height. But you might be able to see that this portion right here that I've highlighted, if you were to cut that off, you could set it over here where I'm putting some blue. You could set it here where the blue is, and that would make that into a rectangle instead, and you could again count. There should be 40 squares in there. The last little bit with this is just in the textbook alone, and so flip back over to that. So the last bit here is just looking at 8, 9, and 10. So in number 8 it says that on a Cartesian plane it is acceptable to label every second point along the axis. Identify the points on each coordinates of each point on the Cartesian plane. So this is similar to number 4, except they've done like I just did, and they labeled every second point. So this value is still going to be 1. So 1, 2, 3, 4. D here is at 5 on the y-axis. So it's done the same, just they've labeled every second point. So do be aware when you're working with some of these, they might label points in a different manner. Also notice, I mentioned earlier, you don't have to center things. This isn't quite centered, it's a little off-center in terms of where the origin is. The axes are off-center, and that's okay too. Whatever works for the graph you're working with. In number 9, here, the points on this Cartesian plane are a little more challenging to read. Identify the coordinates of each point. You may have to estimate if a coordinate does not fall directly on a grid line. So this is a case that happens if we have really big numbers. Sometimes we just don't have room to put, like, a scale of 20 up here and then 20 down here. This could be 40, 50 lines, and so you're gonna have these giant page-sized things. What if we went up to 100? What if you had a point that was at 100 on the y-axis? You could have a really big graph, and so we can change the scale. And in this case, we've changed the scale, and we're counting every block is 5. So we're going up by 5s here. So we take a look at a point like A. It's right on the grid lines, so we can tell you that it's at 5, 10. So the order pair is 5, 10. But in the case of something like B, it's not on a grid line. It's on the 10, so we know the x value is 10, but the y value, it's not even quite in the middle. If I zoom right in on it a little bit here, it's not quite in the middle. So it might even be, instead of 5, it might be at 4. So you got to estimate a little bit. Another example would be like C here. It's at the 10 on the y-axis, but the x value, the first value, is a little bit past 5. It might be at 6. So we have to estimate in some cases as well, depending on the scale of the graph that we're working with. And so the last part here in number 10 was how do the scales on the axes make it more difficult to identify the points or the coordinates of the points shown on this Cartesian plane? Well, if we look at the scales, we have 2 different scales. So the first scale here on the x-axis is going up by 2s. So every square is worth a 2. However, on the y-axis, we're going up by 10s. So here we're at 2 and 20. But it adds some difficulty because we got to pay more attention to the scales instead of just counting grid lines and that. So if we look at D is at looks like at about 5, and then this is 30 to 40 in between here, so that's 35. So maybe 5 and 35 would be the coordinates for D. So it makes it a little bit harder because with the varying scales, because you don't have that nice you have a square grid, but it's not, each square doesn't represent the same height as it does width, and so it can make it confusing sometimes. So you do have to be careful when you're working with these that you do pay attention to the scales. Don't just assume if the x-axis is one that the y-axis is another. It is the same, it might be different. And then when you're plotting your points, again, big part here is to make sure that you recognize x, y is in alphabetical order all the time. Beyond that, that's kind of the general overview of working with Cartesian grids. What we're going to be getting into in the near future here is some linear relations and actually graphing lines, so plotting points and then creating lines on the grids. So do make sure you're familiar with the Cartesian grid before we get into that. That'll be in the next set of lessons that I'll be putting up online. Anyways, that's about it for today. Again, if you guys have questions along the way outside of any live streams and that, make sure you send me an email, send me a message on Edsby, and I can answer those for you.